After providing introduction of the ARM processor, in the very first lecture of this video lecture series, this and the subsequent lectures will explain the instruction set of the ARM processor. That will include the addressing modes and explanation of each instruction of the processor in details. This current lecture explains the addressing modes of this processor in details.
First of all, let us discuss the various addressing modes that are used by the different instructions of the ARM processor. The addressing modes of this processor can be divided into two main categories: addressing modes for data processing operands and addressing modes for memory access operands. These addressing modes are applicable to the operands or the data which is present in the internal register file of the ARM processor, while these addressing modes are applicable to the data which is present in the system memory. This memory is outside the ARM processor. As we know that the ARM processor can process only the data which is present in the internal register file. So these addressing modes are useful for that. But major amount of data is present in the system memory, and therefore these addressing modes are typically used to access that kind of data. The addressing modes for memory access operands are there are further subcategories as shown here. First of all, let us discuss the addressing modes for data processing operands. There are two types under this addressing mode: addressing modes with unmodified value and addressing modes with modified value. Under this type, the operand is used without any additional modification. For example, if you consider this instruction move R0, R1, the data from R1 register R1 is moved to R0 without any additional modification. So here it may be a register which contains a 32-bit data, or it may be an immediate number, but that operand is used without any modification for this operation. For example, add R0, R1, R2. Content of register R2 and R1 will be added. Both are 32-bit registers, and the result will be stored in R0. There are no additional modification. Therefore, that's why this is called as addressing modes with unmodified value. Other type is addressing modes with modified value. In this type, one of the registers, source registers, is either shifted or rotated by using the barrel shifter, and that's why it is modified before it is actually operated. The different types of operations that the barrel shifter can perform are as discussed below. Logical shift left. For example, if you consider this instruction move R0, R1, logical shift left #2. So here the content of register R1 will be shifted to left by 2-bit positions, and then it will be moved to R0. As we know that when a number in a register is shifted left by 2-bit positions, effectively it is multiplied by 4, and therefore effectively this instruction multiplies R1 by 4 and stores the result into the destination register R0. This diagram shows the operation of shifting left, logical shift left operation. When the bits are shifted left, zeros are introduced from the right side, and the most significant bit will go to the carry position. Logical shift right operation is shown here. When the number is shifted to right, zeros will be introduced from right side, and the least significant bit which emerges out will be taken in carry position. The other operations are like this: arithmetic shift right and arithmetic shift left. These two operations are typically for signed numbers. Whenever there is a signed number in register R1 and you want to shift it to right, the operation will be performed like this. When a signed number is to be shifted to right, the most significant bit, which is the sign bit, should be retained in order to retain its sign. And therefore, for example, if the number is negative, this bit will be 1 and that 1 should be retained when the number is being shifted to right, or when the number is positive, this bit will be 0 and that bit should be retained. So this operation is performed when you are doing this kind of operation called as arithmetic shift right operation. The least significant bit which emerges out will be taken into carry position as usual. So corresponding instruction looks like this: move R0, R1, arithmetic shift right, say by 2-bit positions. Content of R1 will be shifted to right by 2-bit positions and the result will be then moved to R0. Similarly, arithmetic shift left operation is performed by this instruction. Here the signed number which is present in the register R1 is shifted left by say 2-bit positions. Zeros will be introduced from the right side and the most significant bit which emerges out will be taken into carry position. You can understand that this operation is actually similar to the logical shift left operation as we have discussed before. So actually there is no physical difference between logical shift left and arithmetic shift left operations. Both operations are same, but there are separate mnemonics available for unsigned number and for signed number. But right shift operations are different for unsigned number and for a signed number. The another possible operations are rotate right. For example, here the number in this consider this instruction: move R0, R1, rotate right R2. Here the number in register R1 will be rotated to right by the number of bit positions which is given in R2. R2 will hold the number and R1 will be shifted to right by that number of bit positions. The rotate right operation is indicated, it's shown in this diagram. The number will be rotated to right. Least significant bit will be taken back into the most significant position. That's how this is rotated, and the least significant bit is also copied into the carry position. The other possible operation is rotate right extended. Actually this is a rotation along with the carry flag. So the 32 bits in the register and a carry bit, so 33 bits are rotated to right as shown in the diagram. So here the instruction is move R0, R1, RRX, rotate right extended. So this instruction actually rotates content of register R1 to right by 1 bit position by default, and the result is stored into R0. So these are the different possible operations coming under modified value type of addressing mode under this data processing operands addressing modes. Next type of addressing modes are for memory access operands. These are the addressing modes for the data which is present in the system memory. Only two kinds of instructions are using this, they use this kind of addressing mode, that is load and store type of instructions. As we know that no arithmetic or logical operations can be directly performed with the data which is in the system memory. The only operation that can be performed by the processor is the data from this memory can be loaded into the internal register file, or it can the content of the register file, data from the register file can be stored into this external memory. So only two operations are possible, load and store operations, and therefore only load and store type of instructions they use these addressing modes. Now there are variety of addressing modes for this under this category. Okay, let us go through that one by one. Register indirect addressing mode. The example is LDR R0, R1. So here the 32-bit address of the operand in the memory is indirectly given in a register of the register file. You know, the external memory or the system memory, every location has 32-bit address, and that address is given in one of the internal registers, and that is indicated by a square bracket. So this shows that R1 contains the 32-bit address of the operand in the external memory, and therefore this instruction will load into R0 the content of the memory location whose address is present in R1. Okay, so R1 will work as a memory pointer, and data pointed by that pointer will be copied into R0. So this is the register indirect addressing mode. Next is relative register addressing mode. In this case, the address of the operand in the memory is specified into two parts. One is the base register, which can be one of the registers of the internal register bank. In this case it is R1, and another is an immediate number. Actually, the address of the operand is generated by adding these two together, and then the content of the memory location pointed by this address is copied, or it is loaded into R0. This typical operation is said to pre-indexing operation. It is said to be a pre-indexing operation. See, indexing means modifying. Here you can see that the content of this base register is modified or indexed by adding this immediate number before the data is transferred to R0. That means the memory pointer which is given in R1 is modified, it is indexed before it is used to copy the data from memory to R0. That's why it is called as pre-indexing type. In this example, R1 remains unaffected. Only the number will be added to R1 and it is simply used to copy the operand to the R0, but the content of R1 is not altered, it is not affected. In the second case, it is pre-indexing plus write back. So here you can see the instruction is typically like this. The syntax of this instruction is similar to this except this additional sign. This indicates that there should be a write back along with pre-indexing. Once again it is pre-indexing, that means as before the content of R1 will be added with this immediate number to generate the actual address of the memory location, and the content of the memory location will be copied into the destination register R0. So this indexing is done prior to the copy of the data to R0, but after that the content of R1 is modified. This new address is put into R1, so R1 is altered, and this operation is called as write back operation, and therefore it is pre-indexing plus write back. The third type under this category is what is called as post-indexing plus write back. Example, the instruction is typically like this, the syntax is typically like this. So here R1 given the square bracket is the base register which holds the base address, and this is the immediate number. In this case, this base address is actually used to copy the operand from the memory into the destination register. After that, this R1 will be modified by adding this immediate number to that, and that will be stored in R1. So here the indexing is done after the copy of the data from the memory to this register. That's why it is called as post indexing. Indexing is done after the data transfer, so post indexing, and also it includes the write back operation because R1 is modified. Therefore it is post indexing plus write back. It is also called as auto post indexing. So these are the three types of operations coming under, say, relative register addressing mode. Next addressing mode is base indexed addressing, indirect addressing mode. In this addressing mode, the address of the operand is specified in terms of two registers. One can be called as base register and other is index register. The actual address is generated by addition of these two contents of these two registers. Okay, for example, in this instruction, the contents of R1 and R2 are added to generate the final address, and that is the address of the memory location. Content of that memory location will be actually copied into the destination register R0. Here R1 and R2 will remain unaffected. Okay, so that means that's why it is pre-indexing. The addition is done or indexing is done prior to the transfer of the data, copy of the data. Next is pre-indexing plus write back. As we have seen before, the syntax is typically like this with this additional sign. So here it is again pre-indexing, that contents of R1 and R2 are added to generate the final address. Content of the memory location is transferred to or copied into R0, and then the new address, which is the addition of these two, is copied into the base register. So base register gets modified. So this is the write back operation, and this is pre-indexing. So pre-indexing plus write back, similar as what we discussed before. And third type is post-indexing plus write back. In this instruction, the base address is given in R1. That address is actually used to copy the content of the memory location, corresponding memory location, into destination register R0, and after that copy the register is indexed. Okay, R2 is added to R1 and the result is stored in R1. So that is what is called as base indexed indirect addressing mode. The next addressing mode is base with scaled register addressing mode. Once again, here the address is specified in terms of a base register, say R1, and a scaled register. Okay, another register which is scaled by shift operation. It may be multiplied or it may be divided effectively by shifting it to left or shifting it to right. So this is the scaled register R2, and R1 is the base register. The address is indicated in terms of these two components, and therefore in this instruction, for example, the address is generated by adding to the base register the scaled register. R2 is shifted left by 2-bit positions. When it is shifted left by 2-bit positions, effectively it is multiplied by 4, and that result is actually added to the base register to generate the final address, and that address is actually used to copy the content of the memory location to R0. Here again R1, R2 will remain unaffected. That's why it is only pre-indexing. Next type is pre-indexing with write back. Once again you can see the difference in the syntax. This is the additional sign. Okay, here also you can see that it is pre-indexing. That means before the transfer of the data, final address is generated by adding this scaled register to R1. Okay, here it is logical shift left by 4-bit positions. So effectively it is multiplied by 2 raised to 4, that is 16, and it is added to R1 to generate the final address, and it is the corresponding data is copied into register R0, and after that R1 is modified with this new address. The new address is stored in R1, so it's a write back operation. This is pre-indexing, so it is pre-indexing plus write back. The third category is post-indexing plus write back. Okay, once again you can see here that whatever is the base address, that address is actually used to copy the data, and after that that base address is added with this scaled register, and it is stored into that base register. So the base register is modified. So here the modification is done after the data transfer, so it is post indexing, and also it is write back. So these are the different types coming under base with scaled register addressing mode. So these are the various addressing modes, as we have seen, coming under memory access operand addressing modes, either register indirect addressing mode or register relative addressing mode, base index addressing mode, or base with scaled register addressing mode.